Hi everyone, my name is Dinesh M, Assistant Professor in the Department of Electrical and Electronics Engineering, Mahindra Engineering College. Today we are going to discuss static relay and its type. First of all, we are going to discuss definition of relay, principle of relay and its type. First we know definition of relay. Relay are electrically operated switch that open and close the circuits by receiving electrical signals from outside sources. They receive an electrical signal and send the signal to other equipment by turning the switch on or off. The major principle of relay is electromechanism. The types commonly divided into three types. Number one, electromechanical relay, then solid state relay, next one, third relay. The first of all, electromagnetic attraction type, also classified into three types. Number one, solenoid type, next attracted armature type, then balanced beam type. Next relay, induction type relay, that is classified into two types. Number one, induction disc type, then induction cup type, and finally directional type relay. First one, reverse current type, then reverse power type. The relay based on timing, they classify into three types. Number one, instantaneous type, then definite type, then inverse time lag type. Depending upon the distance, the relay classified into three types. Number one, impedance type, reactance type, and admittance type. Finally, the differential type relay also classified into two types. Number one, current differential type relay, then voltage differential type relay. Now going to discuss static relay. The relay which does not contain any moving parts is known as static relay. In such type of relay, the output is obtained by the static components like magnetic and electronic circuit and extra. The static units obtain the response and the electromagnetic relay is only used for switching operation. In meaning itself, static, it is nothing but rest. The components of static relay is shown in the given below. The input of the current transformer is connected to the transmission line and their output is given to the rectifier wave rectifying the input signal and passed to the relaying measuring units. The rectifier measuring unit has a comparator, level detectors and logic circuits. The output signal from relaying unit obtained only when the signal reaches the threshold values. The output of the relaying measuring units act as an input to the amplifiers. The amplifier amplifies the signal, gives the output to the output device. The output device activates the trip coil only when the relay operates. The static relay only gives the response to the electrical signals. The other physical quantities like heat, temperature, then volume and extra. It is the first to convert into the analog and digital electrical signals and they act as an input for the relay. The static relay consists of an input circuit that measures the value of desired property, a comparator circuit that compares the measured value to the preset threshold. An operational time delay circuit is control the timing of the switch action after the input has reached the thresholds. The major advantage of static relay, the given below. The number one here, main advantage is no moving parts. So power loss consumption is very low, and also here only used CT and PT, so no losses. And then fourth one is the static relay response is very quickly compared to the electromagnetic relay. Then fifth one, no bearing friction or constant troubles exists. The next, the sensitivity of static relay is high compared to the electromagnetic relay. The use of printed circuits eliminate the wiring errors and mass production is possible. Then last one is the electronic circuits can be used to perform number of functions. The wide range of operating characteristics can be obtained, which almost approach to the ideal requirements. And the testing and the servicing is simplified. In static relay, only made by the semiconductor devices like PN junction diode, PJT and FET, UJT, logic circuits, thyristor family like a SCR, diode and a SCS, then filter circuits and multivibrator. we will discuss one by one. Number one, semiconductor diodes. PN junction diode is used as a semiconductor diodes. It is used to rectifying the signals and regulate the signals, and it is used to take the reference. Number two, PJT and FET. PJT, it is nothing but one type of transistor. It is used to amplifier or switch in a static relay. Then third semiconductor device is UJT, the device having negative resistance characteristics, often used to obtain relaxation oscillators. The output used to trigger the SCR. The logic circuit used to play the important role because it is give the exact outputs. Then fifth one is thyristor family like a SCR, triad, diode and SCS. Such devices used to obtain high-speed switching characteristics. Then filter circuits made by RC, LC, pi filters. RC, it is nothing but resistor and capacitor. LC, it is nothing but inductor and capacitors. It is used to obtain the fast smoothing and phase splitting. The last electronic devices is multi-vibrator. It is used to produce the square waveform from in the static relay. This is the first type of static relay, and it is called static time current relay. This is the block diagram. Here we will discuss one by one. The major input side block diagram is input CT. CT, it is nothing but current transformer. Then second one is rectifying unit, overload level detector and timing circuits. Then again one level detector is connected in between the amplifying and timing circuit. Last block is tripping circuit. The current at which the level detectors trips is called threshold current, denoted as I suffix threshold. When I input current lesser than I thresholds, level detector does not trip. When the input current is greater than I thresholds, the level detector trip the circuits. This is the circuit diagram of static time current relay. Here we are going to use bridge rectifier, then capacitor and filter. It is like a RC filter or LC filter or phi filter. Then the output is connected to the xenon diode. Then here we are using NPN transistor for level detector purpose. This is the second type of static relay, directional static overcurrent relay. Here two inputs are given to the phase comparator. The phase comparator output is connected to the level detector via timing circuits. Then level detector output is connected to the amplifier circuits. Amplifier circuits is amplifying the level detector outputs. Then amplifier is connected to the trip circuits. Then for example, input A is directly proportional to the input current. Then input B is directly proportional to the input voltage. The input A is proportional to the system current supplied to the directional units through auxiliary transformers. The input B is proportional to the system voltage supplied to the directional units through phase shifter. The phase comparator compare the phase angle between the two inputs. Let this angle is phi, while the relay characteristics angle is theta. IP is greater than I cos theta. The output phase comparator is applied to the level detector through timers. If time delay is required, the output of the level detector is amplified and given to the trip circuits. Here two phase comparator used. Number one, Hall effect generator. Number two is rectifier bridge type comparator. This is the third type of static relay, static differential relay. Here only three blocks are used. First one is comparator, then amplifier, final one is trip circuits. Differential relay works on the principle of comparison between the phase angle and two or more same electrical quantities and magnitudes. Comparing these two electrical quantities within a circuit with a differential relay is very simple in application and positive in action. This is the fourth type of static relay. This is called static distance relay. Here also using two types. The major components of the static relay is comparator, amplifier and level detector, finally trip circuits. The final big question is numeric relay. The numerical relay uses a specified digital signal processor like a DSP as a computational hardware along with the associated software tools. The relaying voltage and currents are passed through the isolation transformers. Numerical is the relay in which the measured AC quantities as sequentially sampled and converted into a numerical data that is mathematically or logically processed to make trip decisions. Numerical relay is the latest development in the area of power system production. The design and the methods of the operation, these relay are different from the conventional electromagnetic relay because here output is very smoothing and high qualified signals. Numerical relay are based on numerical devices such as a microprocessor like a MIPI, microcontroller like a MIC, and a DSP like a digital signal processing and extra. Here the major block is microprocessor system or microcomputer or microcontroller system. This is the final blocks. Before the input is ADC. ADC it is nothing but analog to digital converter. Here also we are going to using two type of input signals. Now first one is current signal through a CT, then signal conditioners, then sampling and holding circuits. That sampling and holding circuit is connected to the analog multiplexer. The analog multiplexer connected to the ADC. Then finally ADC is connected to the microprocessor system. Likewise, the second input signal is voltage. The voltage is fed to the voltage transformers. The voltage transformer is connected to the signal conditioners. Signal conditioners is connected to the sample and holding circuits. The sample and holding circuit is connected to the analog multiplexers. The analog multiplexer is connected to the ADC. Then ADC is connected to the microcontroller or microcomputers. The microcomputer or microcontroller or microprocessor is connected to the trip signals. A relay is using digital devices like a microprocessor for decision making based on the digital numbers. Representing instantaneous value of the signals is called numerical relay. The digital relay and microprocessor based relay or microcomputer based relay. The voltage or current signals in the power system are brought down into the suitable level using CT and PT. The signals from CT and PT are given to the filters, which are low pass filters. It's remove the unwanted frequency signals. The signals from the signal conditioning circuits are sampled using sample and holding circuits. With the help of analog multiplexer and ADC, the equivalent digital from the analog input signal is achieved. The analog multiplexer gives the facility to accumulate a larger number of the input signals. The digital output of ADC is given to the microprocessor where it is stored in a memory. The signal is processed with the help of numerical relaying algorithm and according to the trip signals. Trip signal is digital signal, hence converted to the analog using digital to analog converters DAC. This tripping analog signals is given to the trip coil of the relay. Thank you.